Hello, everybody. Welcome to Science Lab. This is the newest video for chemistry topic. And today we are going to deal with or fight with acetic acid. And we are going to deep in the mystery of acetic acid, why acetic acid has formula CH3COOH and not C2H4O2. Let's get started. So before moving to acetic acid, first let's find out why and how carbon binds in with other atoms by a simple example of a methane molecule. This is a 3D structure of a methane. The pink ball you see is the carbon atom, and the four other white balls you see are the hydrogen atom. So let's draw the electron dot structure for carbon. This is a carbon atom, and I'm only going to show you the valence shells of all the atoms, not the inner shells of the. So carbon has only four electrons in its valence shell, that are the four valence electrons. So it has, so as we know that carbon is a tetravalent compound, so it can only share 4 electrons with others. It can neither give electrons or take 4 electrons to satisfy octet or duplet rule. So to satisfy the electrons, we have here 1 electron, and another hydrogen atom shares its 1 orange colored electron here as shown with this carbon atom. So this hydrogen atom now fulfills the duplet rule, as it has 1 carbon atom of 1 carbon atom to its own and its own 1 electron, so that it can form it can fulfill the duplet rule. So it has now another. There is another hydrogen atom, same with the previous hydrogen atom, and other 2 hydrogen atoms. So they all are fulfilling the duplet rules because they all are getting the electrons from the, they are shared with the electrons from the carbon atom, and the carbon atom is also not fulfilling the octet rule because it has its own 4 yellow colored electrons and 4 orange colored electrons from 4 different hydrogen atoms. So keep in mind that here it's only 1 carbon atom. So by the IUPAC nomenclature, 1 carbon atom means meth, 2 carbon atoms means eth, and so on and so forth, like 5 carbon atoms pent, 4 carbon atoms bute, that those are all prefixes. And if only 1 electron is shared, the compound will get a suffix of ane from the family group of alkane. If 2 electrons are shared, then the suffix will be ene, that is alkene, and so on and so forth. So here, there is only 1 carbon atom and there are 4 hydrogen. So if we draw the structure, then there is 1 carbon atom and it is a single bond, because there is only 1 electron shared with the atom, so it's a single bond with the hydrogen, and same with other 3 hydrogen atoms. So by the structure, we can see that the formula of methane will be CH4. So now, as we have figured it out for methane, let's figure it out for acetic acid. So first, we should know that acetic acid is a name for a chemical compound of ethanoic acid. It's a name, it's a colloquial name, it's a layman's language, but the real chemical name for acetic acid is ethanoic acid. So for figuring out its formula, we will be using its proper chemical name. So let's break down ethanoic acid into 3 parts. The first part will be eth. As in the previous slide, we got to know that F means two carbon atoms. So let's get our two carbon atoms into place. We have the two carbon atoms. Now the next part, that's the and. And suffix means that it will be a single bond. It will be a single bond. So let's draw a single bond between the two carbon atoms. Okay. Now, this carbon atom, tell me how many electrons it has been. Yes, that's right. It has shared one electron with this carbon atom. So there are more 3 electrons left to be shared. This carbon atom has shared its one electron with this carbon atom. It also has 3 electrons to be shared. So for this first carbon atom, 3 hydrogen atoms combine with this carbon atom to fulfill its octet. So this is another hydrogen with a single bond, another hydrogen with a single bond, and another hydrogen with a single bond. So this carbon atom now has fulfilled its octet rule because it has its 4 electrons of its own and 3 electrons of these 3 different hydrogens and 1 electron from this carbon atom. Now this carbon atom. Now let's get to our next part, that is the oic acid. Now, in the IUPAC nomenclature or the International Union for Pure and Applied Chemistry, that's the full form of IUPAC, gave a table for functional groups for organic chemistry. In that functional group, carboxylic acid is a functional group of COOH. And if a carboxylic acid functional group is bonded with a carbon atom, then that its chemical name gets a suffix of oic acid. So we just have to draw the COOH bonding, that carboxylic acid functional group. So this carbon atom, tell me how many electrons it has left with? Yes, it has left with 3 electrons. So the side electron here bonds with an oxygen atom, and this oxygen atom bonds with hydrogen atom. So tell me what is the atomic number of oxygen? It is 8. So how many electrons will it have in its valence shell? It will have 6 electrons. So what is the valence of oxygen? It is 2. So as 1 electron is shared with this carbon atom and 1 electron is shared with this carbon atom, and already it has 6 electrons. So it is fulfilling the octet rule. As it is fulfilling the octet rule, it is stable, and this hydrogen has got 1 electron from the oxygen. It is fulfilling its duplet rule. And this carbon atom now has left it with 2 electrons only. Now, in that area, there is only 1 oxygen atom, and that oxygen atom needs 2 electrons. And this carbon atom also needs 2 electrons. So they share their electrons with the double bond. So this carbon atom shares its 2 electrons with this oxygen atom, and this oxygen atom shares its 2 electrons with carbon atom. So all of them are satisfying either the octet rule and the hydrogens are satisfying the duplet rule. So the structure is ready now. So this C atom has bonded with 3 hydrogen atoms. So it will be CH3. And this is the functional group, carboxylic acid, as I told before, COOH. So we will add COOH in this condensed structural formula, COOH. Now we are getting to the conclusion. Because of acetic acid's structure, we have the condensed structural formula CH3-COOH, as we saw it before. And if we combine the structural formula, we get a chemical formula that's CH3COOH. And now, why does it have the formula C2H4O2? We have got the answer now because of its structure. But yes, acetic acid does have a formula C2H4O2, but it's molecular formula. And the difference between molecular formula and chemical formula is that molecular formula is the shortest or the most condensed chemical formula. And its empirical formula for acetic acid is CH2O. So the empirical formula is nothing but is the simplest ratio of molecular formula. That's it. So I hope you understood why acetic acid's formula is CH3COOH and not C2H4O2. And what is the difference between chemical formula, molecular formula, and empirical formula? Hope you got to the formula of IUPAC. And what is IUPAC nomenclature? Most probably. Please see the new videos of chemistry. And hope you subscribe Science Link now. It's a free ticket for subscribe. Thank you. Thanks for watching.